as we are dealing with recursive programs, let us talk about a very interesting concept. It is said that you print 1 to n, all n numbers, without using a for loop. Very simple. You cannot use a for loop, but you have to print all numbers from 1 to n. So say for example, if user says n is 7, you will have to print 1, 2, 3, 4, 5, 6, 7. But the problem is, now it says that n will be inputted by user, but you will have to print all n numbers from 1 to n without using a for loop. How is it possible? It is possible using recursion. So say suppose in a program, in a function which say I name as print to n or print 1 to n. If I call that the name of the function, print 1 to n. If this is the function where I need to print from 1 to n all n numbers, then definitely that function will have to receive an integer n, and as a recursive program it will have to print all n numbers. But see, right now suppose user sends n is 7 in front of you, n is not 1. You will have to start printing from 1 and then go up to 7. But the problem over here is n in your hand is 7. So how can you print from 1 to 7? You don't need to print 7 to 1. You need to print 1 to 7. How to do that? For that, you please understand that if I ever call, if within a loop, within an if only, I will write the if part later. If within a if, I call the same function print to n and pass n minus 1 to it, then you check out it is going from 7 to 6. Suppose it is 7. Next time in the next instance it will be 6. In the next instance it will be 5. In the next instance again it will call and become 4. In this way somewhere or the other it will become 1. If we still continue and say pass 1 to it, this will become 0. N will become 0. So can I say if it is 0, I don't need to print anything. So if n is equal to 0, you just don't need to print anything, you return. But please understand, if you don't return, you call print to 1 to n minus 1. So what happens? Say n comes with 7. Say, suppose from main n comes with 7. N is not 0, so 6 passed. New instance, n is 6. N is not 0, new instance, 5 passed. 5, n is 5. Not 0 still. New instance, again call. New instance, 4 passed. So now in the new instance, n is 4. Still not 0. Again called. In the new instance, n is 3. Still not 0. So next instance, n is 2. Still not 0. In the next instance, n is 1. Still not 0. And again called in the next instance, n is 0. And when it is 0, you are saying your return. Where will it return? It will return to this point because every time it has been called from here only. So if it is returning here, you are not telling it to do anything. You have just called it just like that. Print 1 to n minus 1. Definitely it will go to the next line. If in the next line I printf %d n, then what will it print? Will not it print 1? I will explain you why. See once again, n was 7, it is not 0. You call and create a new instance, n is 6. In the new instance, n is not 0. So again called, n is 5. Not 0, n is 4. In this way, n is 3, 2, 1 and so on. N is 1, still not 0. Again n is print 1 to n is called with a 0. So in the new instance, n is 0. If n is equal to 0, you return. You return here. Here means here. If you return here, what will be executed next? This. Now in this instance, what is n? N is 1. Because n equal to 0 was called when n equal to 1. When n was equal to 1, then only the next instance was created with n equal to 0. So if you return from n equal to 0 instance, here you return with what value of n? With the value of n equal to 1. So what will happen over here? What will be printed? N equal to 1 will be printed. Now after this, if you don't write anything and close, automatically what is happening? Automatically return happens. But see, this return will not happen to main, because again this instance from which you are returning was called from here with n equal to 2. So again it returns here only. And what is printed? N equal to 2 printed. Again over here, n is equal to 2 is being printed, and when you return, it returns here only because it was called from this instance only with n equal to 3. So n equal to 3 is printed. Next it returns again here only because n equal to 3 instance was created from n equal to 4. So it returns here only and prints n equal to 4. Then it prints n equal to 5. Then it prints n equal to 6. Then when it returns here only, where in this instance n was 7. So it prints 7. After that the return will return to main because n equal to 7, that instance was created from main. So it will go back to main. So you call from main, you just call print 1 to n with any random value, say 12. You check out what will happen. From 1 to 12 everything will be printed because printing has been done here only. So from 1 to 12 everything has to be printed. You don't return anything, so this is void return. You only return the control, this is void return. But see, this is a new thing in recursion you are seeing, but 1 to n will be printed. Why I say new thing? Because you have never returned void from a recursive program. But here you really don't need to return anything because the recursive program is itself printing from 1 to 7. Let me try to run it and show you. Alt R, enter. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to 12 has been printed because you called from 12. You did not give a space, so it was printed like this. Give a bit of space. Give 2 spaces like this. See how it looks like. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You may call it with say 24. You check out what happens. It will print from 1 to 24. Everything absolutely fine. You may call it with say 17. See what will happen. It will print from 1 to 17. So everything will be absolutely fine. Now this program is working fine. I will explain once more how it is working. You have called it with 17. So from main 17 is being, n is with 17 is called, an instance is created. But it is not 0. So again another instance with 16, another instance with 15, another instance with 14, another instance with 13, and so on. Up to 1 instances are created. Then n is 0, it returns. It returns to the previous instance where n was 1. So what it happens? It happens is it executes the next line, prints 1. Next line is return, automatic default return. So what does it return? It returns here only from where it was called. So what does it print? It prints 2. Then again it automatically default returns. Returns where? To that instance where n is 3, so it is printing 3, and so on it happens. If I have to show this again by actually the instance diagram, I can very quickly do it for your understanding purpose. Let me save this very quickly and let me show you with the instance diagram. Let me open a Word file. Word file is not opened over here. Let me go and open a Word file. So, WinWord, yeah. So Word file I am opening just to show you how this instance, the diagrammatically how this actually works. See how it works. Firstly, how you had written the function. The function was like this: void print 1 to n, and you received int n, and within that function what did you write? If n is equal to 0, then you immediately return the control. Else you don't return, else you call print 1 to n, and what do you pass to it? You pass n minus 1. Sorry, this is small n minus 1, and after that what you do? You are printing printf. What do you print? You print n, printf %d, and then small n. This is how you have written the program. Okay, so I will just make this small. The auto capitalization keeps on happening. This is disturbing. Anyway, this is else. This is if. Okay, so if n is equal to 0, then this else print 1 to n has been called and minus 1, and after that you have just written print, or else is not done, else is also not needed. If n is equal to 0, return automatically print 1 to n minus 1. This is how I had written it. Let this void, it has been capitalized. Let me make it small. Okay, so how this actually works, I will show you. First thing that I want to show you is an instance is there from main. So let me draw a circle for the main instance, the way I was doing it previously. So here main is present. So I add a text, write main in it. Okay, so this is the main instance. Now from main, suppose 5 has been passed. If 5 is passed, what does that mean? That means 1, 2, 3, 4, 5. 5 should be printed. 1, 2, 3, 4, 5 should be printed. So this I copy again. I paste. And here main is calling this new instance of print 1 to n with the value of n equal to small n equal to 5. This instance is created with n equal to 5. So suppose n equal to 5, this instance has been created over here. Next, what happens? Over here n is 5, so it starts executing. N is not 0, so this if is not executed. So print 1 to n is again called with n minus 1. So the new instance is created over here with n equal to 4. So you check this. A new instance is created. This time its value is n equal to 4. The n value is n equal to 4. Let me connect it with the arrow to show who calls whom. N calls this instance where n is equal to 5. Print 1 to n instance. And then this instance of print 1 to n calls a new instance of print 1 to n with n equal to 4. This n equal to 4, this instance n equal to 4 does not disturb the n value of this instance because it is a separate instance. Is not it so? So now n equal to 4, this will again start executing in the new instance, in its new space, in its new environment. N is equal to 0, return false. So print 1 to n again called with n minus 1, that is with n equal to 3. So the new instance with n equal to 3 is created. So I copy this again and I paste just to show you that this instance has called this in new instance with n equal to 3. Is not so? So n equal to 3 again it starts executing, but in this execution n equal to 0 again fails. It is false. So print 1 to n again called with n equal to 2. So let me copy this together and paste. So here n is not 3 but n is 2. Is not it so? I will just make it aligned. Okay, so this is n equal to 2. So in this new instance of n equal to 2, here it starts executing again if n equal to 0 is false. So again print 1 to n is called, this time with n equal to 1. So again a new instance is created with n equal to 1. I just copied it and I paste it. So this time what is the value of n in this new instance? The value of n is 1. So n equal to 1. Next what happens? Int n. Here it starts executing again. N equal to 0 fails. So again it calls print 1 to n. This time with n equal to how much? With n equal to 0. So this time with n equal to 0. With n equal to 0. So now you see what happens. If n is equal to 0, here a new instance has been invoked with n equal to 0. If n equal to 0, return. So it returns, this instance was executing, it returns. If it returns, that means I will have to return or go back to this instance. If I go back to this instance is dead. In this instance, what is the value of n? Equal to 1. But where is the return happening? To the point from where it was called from here. It was called from within print 1 to n function, means it was called from this point. So it has returned, the control has returned to this point. This is executed. So next what will be executed? Next printf %dn will be executed. What is happening as a result? N is being printed. N is being printed means what is the value? I mean this instance. What is the value of n? The value of n is 1. So 1 is printed and you put 2 spaces in between. So again after printing 1, 2 spaces are printed. Check this, because I have returned here only. Now after printing 1, what is the next line? Next line is a default return. That means it will return, but this instance, if it returns, it will return where? It will return not to main, but you see it returns here, which is an instance of print 1 to n function itself. Now print 1 to n function invoked the print 1 to n function again from here, which means it returns here only. So what is the next line it will execute? It will execute this line only. So it will print n. What is the value of n in this instance? 2. So what will be printed over here? Definitely n's value is printed. N you are printing means it will print 2, because in this instance n's value is 2. But after printing, what is there? The next line? The next line is a default return. So it will again default return to this point itself. I just paste it and copy it here. Okay. So it again defaults returns where? To an instance of print 1 to n. So print 1 to n called a new instance of print 1 to n from here only. So the return happens there only. So the control is here. So what is the next line executed? Again n is being printed. What is the value of n in this current instance? 3. So what is being printed? 3 is being printed. After printing thing, what is the default next line? Default next line is return. So it will return here. So what will it print again? It will print 4. Again it will return. What will it print? It will print 5. Again it will return. When it returns, where will it return? It will return to main. Do you understand this? From here it will return. It will print 4. From here it will return. It will return here. It will print 5. After that, the default return, you see it returns back to main. It's not so. If it returns to main, that means up to 5, 1, 2, 3, 4, 5 will be printed. If you call it with 6, more instances will be created. If you call with 7, 1 more instance will be created, and so on. But it will keep on printing. So do you understand this? This printing has happened without a for loop, only using what? Only using the concept of recursion. Recursion is really a very nice concept, as you can see. But you see, recursion is not always very good to write. Writing recursive programs might be very easy at times, but writing it always is not a very good, what should I say, a good practice at all points of time. Sometimes it is very good, but you will have to be very careful where you are using recursion and where you are not. I will show you one more example where writing recursive programs might not be a very good idea. What is that? I will show you Fibonacci series. Do you remember Fibonacci series? What is Fibonacci series? A series which is 1, 1, 2, 3, 5, 8, 13, 21, 34, then 55, then 89, and so on. How was that calculated? If you remember, this 1 and 1 are by default, but this 2 is created by the addition of the previous 2 digits 1 and 1. So this is 2. This is 3 because the previous 2 digits are 1 plus 2 makes it 3. This is 5 because the previous 2 numbers 2 plus 3 makes this 5. This is 8 because the previous 2 numbers 3 plus 5 makes it 8. This is 13 because the previous 2 numbers 5 and 8 makes it 13. This is 21 because the previous 2 numbers 8 and 13 makes it 21. And so on. You check out, this is happening. Fibonacci series. Now if you have to write it normally using a for loop, then using a for loop you have done it previously. Now I ask you to write Fibonacci series, a function which will return the Fibonacci number if the position is given to you. Say for example, the position given to you is 6. If user gives you position 6, what is the Fibonacci number? See, this is position 1, this is 2, this is 3, this is 4, this is 5, this is 6. So in the 6th position, 8 is present. Your program should return 8. If a user enters the position is 9, then you should return 34. Because see, after 6, this is 7, this is 8, this is 9. So it should return 34 in the 9th position. If user says 10, then you should return 55, because in the 10th position 55 is present. See, this is the 7th position, this is the 8th position, this is the 9th position, this is the 10th position. In the 10th position 55 is present. So it should return how much? It should return 55. You understand this? So it will accept a position and return the number present in it. So see, don't you think that if the function is like this, say Fibonacci function is like this, where you receive position, then Fibonacci position is basically Fibonacci position minus 1, whatever Fibonacci number is there in position minus 1, added with whatever Fibonacci number is present in position minus 2. Please see this. Whatever Fibonacci number is present in position minus 1, added with whatever Fibonacci number is present in position minus 2, added together will give you the Fibonacci number in that position. Is not it so? But this is normally, but you need an exit case also. So the exit is Fibonacci 1 is 1. Another exit, Fibonacci 2 also given is 1. You remember, the first two positions are given as 1 and 1. So Fibonacci 1 position is 1, Fibonacci 2 position is also 1. But other positions is Fibonacci position equal to Fibonacci position minus 1 plus Fibonacci position minus 2. This recurrence relation will work. Why? Because suppose you are given Fibonacci 4. So you calculate Fibonacci 4 is Fibonacci 3 plus Fibonacci 2. But Fibonacci 3 is again Fibonacci 2 plus Fibonacci 1. Fibonacci 2 and Fibonacci 1 given. So 1 plus 1 makes it 2. And then you calculate this part. Fibonacci 4 was given. So Fibonacci 3 and Fibonacci 2. Fibonacci 2 is also 1. So 1 plus 1, this was 2 and this is 1, 3. So Fibonacci 4th position is 3. See, Fibonacci 4 is 3. This is how you calculate it. So writing this program should be very easy. So here you are supposed to return the number in that position. So your return type is not void but int. So it is Fibonacci, the number, let me write the program or the function as Fibonacci. It should receive a position. It should receive a position, int position. So here you write if n is equal to 1 or position equal to 1. If you write this position, not n, position, if position is equal to 1 or the position is equal to 2, that is what you have written. See, if you really look at it, what you have written, if position is equal to 1 or position is equal to 2, in both cases you return 1. Please understand, in both cases you are returning 1. What I have written, if Fibonacci 1 is 1, Fibonacci 2 is also 1. So I explain this. Let me complete this. Yeah, this is the bracket. So see what I have written. Fibonacci 1 is 1, Fibonacci 2 is also 1. So if the position is equal to 1 or the position is equal to 2, you return 1. Else you return something else. Let me get rid of this. Else what do you return? Else you return, see what you return. Fibonacci position minus 1 plus Fibonacci position minus 2. See this. That is what you had written in the recurrence relation. In the recurrence relation, you have written if Fibonacci 1 equal to 1 and Fibonacci 2 is equal to 1. So if position is equal to 1 or position is equal to 2, you return 1. Else return Fibonacci position minus 1 plus Fibonacci position minus 2, because this is the thing. This program will work fine. You see, you can print and check out. So printf %d followed by Fibonacci. Say you call for 8th position. You provide the 8th position and see what it prints. What should it print? What is the 8th position? You check out the 8th position is 21. It should print 21. You have called it with 8th position. So you have said that in the 8th position, if it is 1 or 2 position, you return 1. Else you return Fibonacci position minus 1 plus Fibonacci position minus 2. Let me see how it works. I will save this once and try to run it. Have I commented out? Yeah, everything commented. So let me try to run this program. It should print 21. See, 21. Absolutely fine. You can also try out with say 10. 10 should return 55. Is not it so? Please check once. 10th position, what is the number present? 10th position, the number is 55. Let me try to run it again. I save it and try to run it. 10th position, 55. So everything works fine. But I was telling you that writing Fibonacci like this is not a good practice. I will tell you or explain you again with that same old diagram. I will show you with the same old diagram. See how. I will save this and quit. I will show you that why this Fibonacci writing like this is a bad habit. I will open the Word file once more and show you. Okay, so this is the Word file. So the program that I had written a while back, or the function I have written a while back, was looking like this. Int Fibonacci, I have received a position, int position, and there I checked if position is equal to 1. If position is equal to 1 or position is equal to 2, then what you do is you return 1. Else you return Fibonacci. See what? Fibonacci position minus 1 plus Fibonacci position minus 2. Is not it so? You please check out. I will just delete this and show you. Yeah, so you return, otherwise you return Fibonacci position minus 1 and position minus 2. I will just correct this auto capital thing. This was also auto capital thing, I will correct. And here you just end. So that is the program for you. This program I am saying, this function I am saying, is not a good thing to have. See why? I will tell you why. Firstly, let us have the instance of main. So let me draw the shape for main. This is your main. So let me write main over here. Suppose main sends the position. I need to make it a little bigger. Okay. So this is main. So let main call this Fibonacci or this Fibonacci instance. So this Fibonacci instance is being called by main. So suppose you look at this. The Fibonacci instance is now created with, suppose, a value of position equal to 5. Suppose with a value of position equal to say, make it 4, not 5. Make it 4, because even 4 will be so clumsy, you will get to understand why I am saying all this. Say with position equal to 4. So say suppose here you are with position equal to 4. So it starts executing. It is neither 1 nor 2. So this is false. So here it is. Else is not possible, else return is not possible until and unless you add. Addition is not possible because here you have called position minus 1. You have called Fibonacci with position minus 1. Let this f be small. Sorry. You have called this Fibonacci with position minus 1. So a new program, a new instance has been called for with position equal to 3. I am drawing it on the left side just to explain to you that it has been called from the left one. See what I try to explain, what I am trying to explain. Here you may call from two positions. You may call from here or you may call from here. From where you call, to explain to that here you are calling from the left side. So I am going to this left side just to indicate that the call has been done from the left side. So position equal to 3 it has been called. So this int position, again it starts from beginning. This if is false. So else again. Return not possible until and unless addition happens. Addition not possible, again a call has been done with position minus 1. So new, again it has been called with position minus 1. Again on the left side I go again to the left side. So here I just go to the left side and this one has been called with position equal to 2. Now you check, position is equal to 2. So here this if, again it starts from the beginning. This if is true. It returns 1. So what does it return? It goes back. It returns 1. So here it returns to this point. With what value does it return? It returns with a value of 1. So let me insert a text box and write that 1 that it is returning. So it is returning just a 1. Check this. I will just make it smaller and decrease the size of this so that it fits. I'll just decrease the size of this to a small one. Oh, not so small. Anyway, so this is the one that I was talking about. So it is returning this 1. I will make it a little smaller. Okay. So this is returning 1. So where has it returned? It has returned to this point. It has returned to this point. Why? I know it has returned from the left side. So it has returned to this point. So now again plus. It needs to add. It has returned here means now it needs to add. But addition is only possible if you call again. So again it is calling with Fibonacci position minus 1. I am here. Position value is 3. So I again call, but this time I call from the right side with position minus 2. So don't you understand that a new instance will be created, and here this new instance will be created with the value of position equal to 1, because here position is 3. I am calling again with position minus 2. So here I am calling going to the right side. Just I am explaining this why I go to the right side. I go to the right side just to show to you that it has been called from this one, right side one. So here with position equal to 1. So again I start from the beginning. So again I start from the beginning. If I start from the beginning, then again this if position equal to 1 or position equal to 2, return 1 is true. So what does it do? It returns 1. So now it again returns. Where does it return? It returns here only. And what value does it return? It returns the same value of 1. So it returns the same value 1 over here. Now see, both have returned 1. So I am now over here with a value of 1. Remember previous time here also 1 was returned. And here also 1 has been returned. So 1 plus 1 will be added now. Both have returned. The control has returned. So over here this plus will happen. That is the addition will happen. So 1 plus 1 makes it how much? 1 plus 1 makes it 2. Now return 2 that is being executed. So I am here, I am in this instance. Return 2, where will it return? It will return here. So see, it will now return, I will just copy this. Now it will return, okay, so this has been copied. Okay. So now I will return to here to this control. What value will I return? I will return not 1, but I'm returning 2. So check this. This instance has returned to the first position with a value of 2. Check this. 2 has been returned. I have executed return 2. So because I have executed return 2, I have returned here only. But where have I returned? You see, I have returned from the left. I have returned from the left means I have returned here. You may get confused. Have I returned here or have I returned here? Definitely I have returned here because I have returned from the left side. Please understand this. I have returned from the left side. So I have returned from the left side means addition not possible, because again you need to call Fibonacci position minus 2. That is, I need to create a new instance with position equal to 2. Do you understand this? Because this is now invoking position equal to 2. I copy this just for our purpose to be made a little easier. So here it is now calling with position equal to 2. Please see this. With position equal to 2 I have called this. So here I am present at the very beginning because I have been invoked. So I am here only. If position equal to 1 or position equal to 2, return 1. So what will it do? It will return 1. So this same thing, I copy and paste. So here I return how much? I return 1 only. Why do I return 1? Why am I saying I am returning 1? I am returning 1 because I am present over here. Position is equal to 2. I have been called with position equal to 2. So this if is true. If this if is true, I am returning 1. So 1 is being returned. So see, I am here means where am I? I am actually here because I have returned from the right side. What have I returned? 1. What was there previously? 2. So this is 2. This is 1. So 2 plus 1 makes it 3. What am I executing? I am executing return 3. So see, where will this return now? Return back to main. So that means what is it returning back to main? It is returning back the value 3. You see, this 3 value is being returned back to main. So now this 3 is being returned to main. Why did it return 3? Because 4 was sent to it. What is there in position 4? If you look at the Fibonacci series is 1, 1, 2, 3. So if you look at the position, this is position 1, position 2, position 3, position 4. What is present in position 4? 3 is present. So it is returning 3. Why was I saying this is clumsy? Because do you understand how difficult it is to create the Fibonacci series? How many instances are being created? Say, had I sent 5, then 5 would have been somewhere. You just think like this. If I send 5, then what will happen next? I will show you what happens next. If I call it with 5, see this. I just copy this whole thing. This entire thing I select. Okay. So this selection is not being possible togetherly. Anyway, I am trying to. Okay. See what is happening. Had I called with 5, then what would have happened is with position equal to 5, it would have first called for position equal to 4. Then this whole thing would have been executed and returned over here to 5. Then from position equal to 5, it would have called position equal to 3. Then with the instance position equal to 3, it would have again called for position equal to 2 and position equal to 1. And then it would have returned here. Then it would have again computed and again returned. Do you understand how many times it is happening? See, only in this small thing, position equal to 2 was computed twice. If I would have called with position equal to 5, if I would have called with position equal to 5, then see, it would have called with 4 and 3. Then under this whole 3 would have been done over here, and 3 would have been done over here. Please understand this. Is not so? Is not so? If I can somehow select this, if I can somehow select this and make this a little downwards, then I can show you easily. I will, it is not happening somehow. I'm unable to select them togetherly. I don't know the reason. Anyway, I'm trying to do it again. Okay. So if I just bring them a little downwards, I will be able to show you. Let me select all this togetherly again. I will be able to do it if I can get hold of it togetherly. If I can also get hold of this togetherly, see. Okay. So if I can bring it over here, this whole thing I have just shifted a little downwards. You see this. What I have done? I have shifted this a little downwards. Why? Now I want to show you, if main would have called the Fibonacci function not with position equal to 4 but with position equal to 5, what would have happened? See, if it would have called with position equal to 5, then what would have happened? Here it would have been called with position equal to 5. Let me copy this and paste. I add a text over here and paste there position equal to 5. Suppose it is being called with position equal to 5. Then once it is called with position equal to 5, what would have happened? This if would have been false. Then the else part, else return would not have been possible without the addition. Addition is not possible without calling for position minus 1. So position equal to 5 would have called for position equal to 4. That is, this would have invoked the new function of Fibonacci with position equal to 4. That is, this would have called for this. And then this whole thing would have been executed. This whole thing would have been executed. And then finally, after executing this, when I return from here, 2 plus 1 equal to 3 would have been computed, and that 3 would not have been returned to main. Instead, that 3 would have been returned to where? To position equal to 5. That is, I can say that here, if I insert this, this would have called for, this would have returned here with the value not equal to, this 3 would have been called, this 3 would have been returned, 2 plus 1, 3 would have been returned, not to main, but to this new, this position equal to 5 instance. So this return would have been where? Would have been here. Then this addition can be done only if I call for Fibonacci position minus 2, which means it would have now called for position equal to 3. It would have now called for this position equal to 3 on the right side. You see this? This position equal to 3 would have been called for. This 5 would have called for position equal to 3. Is not it so? Because I am calling for position Fibonacci position minus 2. So if I am calling for Fibonacci position minus 2, that means I am calling for position equal to 3. That means here I need to insert this arrow that this Fibonacci position equal to 3 would have been called for. And if position equal to 3 would have called for, then this whole thing would have been executed again. Please understand, this is executed once. This would have been executed again over here. That is, this would have all remained. If I can select them together again, I will show you. So I have selected, and I will, okay, no, I will also select this and this togetherly. I have selected. If I paste them and just bring them here, then you will be able to see that 3 would have again called for this whole thing. So this 2 and 1 would have been again called for, this 1 and 1 would have again been returned, and if this 1 and 1 again been returned, again this 1 plus 1 would have been computed, again this 1 plus 1 would have returned 2 over here. You see, this 2 would have been returned again over here. You please understand this. Again this 2 would have been returned here, and if this 2 is returned over here, then this, you see this, here this 2 would have been returned. If I return this 2 from the right side, what does it mean? Where am I present? I am present here, here I am present. So this and this would have been added together now. What has been returned? 3 has been returned, 2 has been returned. So 3 plus 2, 5. 5 has been computed, 3 plus 2. So what am I executing? Return 5. So where will it return? It will return to main, because main called it. It returns how much? It returns 5. So if I copy this and again take it over here, this would have returned 5 to main. So see, 5 is being returned because position is 5. Check out what is in position 5. This is 3. After 3 is present, 2 plus 3, 5. This 2 plus 3 is 5. So what is in position 5? Position 1. This is position, check out 2. This is position 3. This is 4. This is 5. What is present in position 5? 5 itself. 5 would have been returned. But for doing that, please see what has been executed. Position equal to 5 invokes position equal to 4, which invokes 3. 3 again invokes 2 and 1. So 2 and 1 again returns. This whole thing is again invoked here. In fact, this 3 has been invoked twice. See, position equal to 2 invoked how many times? 1, 2, 3 times. Position equal to 1 invoked twice. See this, is not it too messy? What does it mean? It means that I will have to avoid writing Fibonacci using recursion. Had I done it using a simple for loop, I could have so easily done it. Say in this program, if instead of doing it using recursion, I would have used for loop, then how easily it could have been done? Yes, writing it would have needed a logic. So it is sure that I need to get rid of recursion while writing for Fibonacci. I can do it using a for loop. So I can start with for I equal to how much? I will have to go till position. So I can say if position, same thing, if position equal to that thing remains, if position equal to 1 or position equal to 2, then what do you need to do? You need to return 1. That thing remains the same. That if it is 1 or 2, yes, it is 1. But if it is not 1 or 2, then what I need to do? I need to do a simple for loop. How to do it? For loop. For I equal to 1. What I do is first and second. You remember how I did it? I will need a variable called f. First. First is 1. Second is 1. And third is always first plus second. It's not so. First position is 1. Second position is 1. And the third position is always first plus second. So for I equal to 1, what will I do? I will continue. I will put the end point at the end. See, for I equal to 1, I plus plus. Third is equal to first plus second. And then what will I do? Then I change first to second. Then I change second to third. And I continue. See, t equal to f plus s. Third is first plus second. The second is now copied to the first. And the third is now copied to second. This is how I had written the logic. If you don't remember, please go back to Fibonacci where I actually showed you how to write Fibonacci and understand the logic. So here I need to define also. Here I need to define int first position, second position and third position. This I need to define. However, if position is equal to 1 or position equal to 2, you return 1. Else only this part needs to be done. That is f equal to 1, s equal to 1, and then you start doing this whole thing. How long should I continue? See, if the position is given to you as 3, then only once it should be done. After this for loop, I should return how much? I should return the third variable. So here I should do how many times? Only 1 times. But position is 3. If position is 3, then I need to do it once, because only 1 plus 1 twice it will happen. So how will I write it? I less than position minus 1. Position is how much? Position is 3. Position is 3 means position minus 1 is 2. I less than 2 means it will execute only one time. If it executes only one time, then t variable is f plus s 2. So it will return 2. You remember, if position is 3, then what do you need to return? You need to return 2. I will explain why. 1, 1, 2. So if position is 3, then what do I need to return? I need to return 2. So your f and s is 1 and 1. So this loop should be executed how many times? Only once. T equal to f plus s only once will execute, will return your 2. So this return t should execute. So if position is 3 means 3 minus 1, 2, less than 2, it will execute only once. This is how you have computed the logic. And this whole thing will work absolutely fine then. You see, you now also save this and try to execute it for 10. Okay, undefined symbol I. You have defined everything but not I. So let me define this and then try to execute. Say 10. Yes, 55 is printed. In the 10th position, what is present? 55. But see, this is very good. This may be difficult in writing the code. You need to have the logic. You need to think of the logic. But still it is good to write the code in this way, because it will execute only once. This for loop will only execute from 1 to 1, and it will return the result. It will not create so many instances or not create a thing which is so bad. Is not it so? So here in Fibonacci series, it is better to use a simple for loop than going for a recursion. I will do few more programs with this recursion also. Let us take a bit of break. Try to understand this again. Try to go through this once more. Try to understand this again. We will come back after a little break. Thank you so much.